This is a 2024 Toyota Tundra hybrid with the V35A 3.4-liter twin turbo V6. This engine has created such a giant buzz of problems, and then a recall followed and everything. And this is actually a new engine. And you know what? This happens to be my own personal car. I like this engine. I like the way it drives and everything, but there is a lot of issues with this engine. And in addition to having this truck here in the shop today, we have this. This is actually a V35 engine. Not out of this particular truck, but other truck just like it. This engine was donated to us here at the shop. It's not a complete engine, but for the most part, everything important is there. Let's dive into it. Let's kind of explore it, take it apart, see how everything is at. There's what's the small details of everything. We'll check it out because it's a good education for me. It's good education for you. We'll check it out. You know, I don't work at a dealership anymore, so these are dealership technicians. Don't hear nothing about this right now because of the engine recall. But for us, let's do some exploring, see what we find right after this. Let's take a look around this engine before we tear it down and look into it. There are a few interesting things. First thing is, this is that two-piece front timing cover. So this is the front piece. This is where the water pump would be, oil filter and cooler and whatnot. But here's the interesting part. So this is a two-piece front cover. You look at it right here. There's this front cover. This is the actual front cover. This is the back cover. The idea here is where the cylinder head meets the block, there is nothing. You see that there's no sealer. That's where they used to leak. That was the whole point of doing this whole thing. The problem is now we have a lot more sealer that could leak. So far so good, but we'll see. This engine, of course, twin turbocharged, Titan's turbo, kind of on a smaller size. Here's that electronic wastegate that actuates this. Really dislike this. This is not at least, but I'll say one thing. We gotta be fair here. This engine has a lot of issues. It's not a plastic one. I've seen a lot of manufacturers use plastic, which is a horrible idea. This one is, I'm gonna say it's aluminum. Looks like aluminum. But if you come around here, if you're not familiar with what a wastegate is, when it's open like this, the exhaust will all come out of here and not spin the turbo. When it's closed, it's actually going to start spooling up the turbo. So that's how the engine computer controls how much pressure this turbo is making. So it wouldn't just spin into infinity and take this engine out with it. With that, let's talk about a few interesting things here. Do you see this valley? Some folks with V8s will think this is a valley plate. This is actually not a valley plate. This is a ventilation case. Fancy word for oil separator, basically a catch can, a glorified catch can. My only problem is, did we really have to put it right here, Toyota? And then the biggest problem is with something folks might not know about this engine. The PCV valve is here, right on this case. And just let me just remind you one time, this is the front of the engine. So to give you a reference what that actually is in the car, looks very different when we're in the car. It's all the way in the back. You can't even reach it, can't even see it because it's behind the intercooler and everything. So here's how the top construction of this is before we even dig into the internals. So you have that case, then you have an intake manifold here, which connects directly to cylinder heads. And then you have a little, kind of a shallow plenum that comes around, and that's what actually connects to the back of this intercooler, which is liquid to air intercooler. And that's what you're looking at here. So underneath it, that big plenum is gonna sit here and then wraps around. That's where the intercooler connects to it. That's what you're looking at there. And if you look here, this is where your direct injectors will go. There's 3 of them, and then 3 on the other cylinder, and then the port injectors will sit up top. That is the front. Now, one thing about this engine, by the way, the spark plug tubes have been cut out. This is how we got it. Not a big issue, but just letting you know that there are spark plug tubes there. And it's missing the cam tower. Just we didn't get it with it, didn't get the cams or the rest. We got the chains, but not the rest of it. So we got it. We're grateful that we got it to kind of look and check it out. So if you look here in the back, this is kind of a strange one for me. So this is the rear of the crank. This is where your rear main seal will be. That's a pretty large plate. Usually they're a lot smaller. This thing is massive. Why? Must be a reason. But I'd say it's not a good one because that's a lot of sealer that could leak in the future. That's such a hot area. And then looking in the front here one more time, I like this style of VVTi control because this, I can get it out, all it is a plunger that comes out like this, electronically controlled, and then the VVTi gear itself, the bolt that holds it, it is the OCV valve. This is just pushing that valve in and out to change the angle of the cam gear. I think that's a pretty cool design. They started this with the 2G RFKS. I like it. It's better than the OCV valve being on top of the valve cover, for example. Then there is the strange stuff. And this is, yeah. Why does this have to be right here? Just right against the block. Couldn't we maybe make this a little bit better? Space-wise, maybe they couldn't fit it. I mean, this thing is a giant behemoth. Could have made things spaced out a little bit. They didn't. That's okay. Then I am just mystified by what exactly is this? That just goes nowhere. It's just an opening. I can't wait to tear this down and actually see if this does anything, because they're on both sides. There's one right here as well. Then oil return, oil supply. This is just for the turbo. Connect right here. And it looks a lot smaller. When you look at it in the car, it looks like this massive behemoth that's just busy. It's just a V6, folks. To me, this is actually potentially smaller than a 2GR. And 2GR is 3.5. This is a 3.4. So it's actually very compact. Now, I wish they would have pulled the turbo a little bit out to give you a little bit more space for service. They never think of that. But you notice the integrated intake manifold. So there's the turbo bolts directly to the cylinder head. That is pretty cool. Having said that, let's start kind of peeling off the layers. Start tearing into it, and then we'll check out. We'll get to the infamous main bearing here. Check it out. See, I really haven't torn this engine down. We wanted to tear it live and kind of go on a discovery learning about this engine, because it looks like this is going to be the future. So we're all for education, problems or not. Gotta learn, gotta know our stuff. So let's take off the front cover, or the outside front cover, I guess. This is just bolts that we use to secure it. So this is the first layer of the front cover. And that's the second front cover. So we are missing the gears and the chain and whatnot. But here's the interesting part. The oil pump is actually not part of the front cover. You see there's nothing here, because the oil pump is actually right here and it's chain driven. That's the interesting part. Over here you only have coolant, a little bit of coolant right here for the water pump, and that's all we got. Front crank seal. I'm gonna tell you the truth as we go through this engine. I really dislike this style seal that they started using. Started this with a 2G RFKS. Why exactly does this seal have this lip? In my opinion, as a technician, the only reason this has it, so it makes your life very fun. Now you have to have the exact special tool that fits over this, but not too wide, to install it. Because for the longest time, they used to have flat seals that doesn't have this lip. 2G RFKS, we started getting the lip. It's a very skinny cover. And they have this humps now because of the plastic valve covers. You got to put sealer here. It's lightweight, very skinny, strange shape. They do give you access to the tensioner. Actually, that's kind of an interesting shape. This is something they started with the A25. Now they use a lot of these 8mm bolts. Let me take this out. I want to see the size of it. Okay, that's an interesting shape. Actually, I wonder why is it this shape? Probably couldn't make it bigger. It's kind of an odd shape. Odd that these are here. But this is to access the tensioner, supposedly. They did that on the 2GR, FKS, and the regular, the FE. Never worked. You can't. Yeah, that's just maybe inspect the chain. If the tensioner is stretched all the way out, you know the chain is stretched. Speaking of the chain, here's the chain for this engine. This is the main chain. So this engine has two chains. This one runs from one gear to the crank and then back to one gear and then kind of loops down and comes up. I just gotta say one thing, and the truth have to be said as it is. It's not as kind of see you in 500,000 mile feeling. It just doesn't. It's actually a lighter chain. That's kind of a surprise, Toyota. I mean, for the longest time, we never have chain problems. I mean, I'm not saying they do. Time will tell. This doesn't feel as robust as, say, a 2GR FE. I mean, that's a much heavier chain than this. I wish we had one around. I tried to look for one. This is a secondary chain. So this one, not as this doesn't get a lot of load. This basically goes from here to here. Here's the oil pump. Pressure relief valve. Interesting location for this oil pump because I feel like this is better. So this is how they used to do timing chains for the oil pump. This is a little chain that goes from the crank to the oil pump. Then you have a little spring-loaded tensioner that just has like a little guide and tensioner. That works. And they've had it for years and years. I don't think they had any issues, but having the front cover in the nose of the crank worked as well. That's the one thing they changed from that. So just to give you reference how this opening is for the timing chain tensioner. So the timing chain tensioner sits right here. And when you put this cover on, let's find the guides for it. So you have direct access to that. That's the whole point, that you can pull the tensioner through this opening, which never happens. So this is the inner timing cover. Let's pull it out so you guys can see it, the whole point of it. So you can't pull this inner cover without pulling all the chains out. I'm sorry, I forgot to say this. Between the cams, there's another chain here, and a tensioner. That's the same design as a 2GR, FKS, and FE. So the whole idea here, I'm gonna put this here so you guys can see it. In the past, majority of oil leaks were in this weak area where the head meets the block. In the past, we used to have sealer continuous here. So this area is so weak because you have a big void there. And that's where these used to leak from the front cover. Not these, but the engines that had that design. So here, they bypassed that completely. Here's how they did that. Because we have the two covers, so you have sealer here for the top part, you have sealer here, and then you have sealer over this bottom part. You actually have nothing here. You do have a little passage that goes in the middle, but you don't have anything else here. You don't have oil, like oil leak from the front cover on the edges. That's the whole point. Honestly, I just gotta say it. It added a significant amount of parts to this engine. And I'm sorry for the engineers that designed this, but I just gotta say it. Was this worth it? I hope it works, because if it doesn't and this ends up leaking and this ends up leaking, now we just overcomplicated the engine for nothing. So we'll find out. Time will tell. So far so good, at least that I've heard of or seen. So the oil pump is part of the second timing cover, which I can live with that. Here's the front. Now we have just the cylinder head and the block. Let's take one of the turbos out. We can lighten up cylinder head, check out the turbo. and then we'll continue here. Very small turbo. Kind of surprised a whole bit. Tiny turbo. And see then, there's a little bit of play, but I'm gonna say that that's probably normal because this turbo is dry. It's been out for a very long time, this engine, folks. So if you're not familiar with turbos, exhaust comes out, spins this inner part. That inner part is connected to here. This starts compressing air and it comes out. Pulls air in here, compressed air comes out, goes into the engine. More air, more fuel, more power. That's the whole idea. Let's pull the cylinder head out. Let's take a look at it. Very small. I just gotta say, this is a lot smaller than a 2GR engine. This is mainly what we're comparing it to. I'm noticing a few things. First, we have this, I almost want to call it suspended bridge in the middle where everything sits on. It does have like pillars here, but here it's kind of like floating. That's interesting. I'm assuming to make it lighter. You do have lifters. Unfortunately, we don't have all the parts for it. But there's a hydraulic lifter out of this engine. Looks very similar to 2GR. Pretty similar design. This does have roller rockers and whatnot. Basically, we sit here, the valve would be here, and the cam will push down on it. But the interesting thing, this is a new style valve guide seals. At least color-wise, I've never seen this color before with Toyota. They're usually gray or brown or black, and these are green. Very cool. It works. Then the integrated exhaust manifold looks just like that. I always see these plugs, I wonder what they are. If you're into engine design and whatnot, what is the purpose? Maybe something with casting or whatnot? Because it does absolutely nothing but just sit there and be in the way. Let's look at the front side. There we go. Unknown mileage on this engine, but I'm assuming it is not very high mileage. That's a bit on the, how should I say, not very clean side. Here's the biggest concern I have with this. Now, we received this engine kind of all the parts thrown in it. We didn't touch it for a very long time. Here's a concern. This is an intake valve. I'm going to put these intake valves here. This is a D4S engine. What happened here? That's the beginning of carbon buildup, folks. That's not good. And I've actually seen this before with this engine. For some reason, it does build carbon on the intake valves. It's very, very interesting. It doesn't run super clean, this engine. I mean, this can't have over 100,000 miles. I wish we knew the mileage on this engine, but look at this. It's kind of, I'd like to see it's a little bit cleaner than that. That's not the greatest looking. I mean, look at this one. Here's another one. That's how carbon buildup starts, folks. Before you know it, this thing is like a giant dome and it starts blocking. This valve, surprisingly, is clean. Exhaust valves. Flat exhaust valves. The old ones used to have like a indentation in them in the middle. These are flat. Interesting. So that's the cylinder head. For the most part, otherwise, like this side looks very similar to 2GR. Maybe this is a little bit of too sharp of an angle. I feel like 2GR was more. This was more rounded. This was like a big cut. This is where the injector is going to spray. And some of this debris is just from storage, but you can see the area where it's shining some light here. You see the area where this is like black, and this area is very shiny. That's where the injector is spraying. So that's a lot of build-up in a short period of time. Again, unknown miles. Maybe this did have over 100,000 miles. Looking at the back here, don't have much going on. We got another one of these plugs. And the cam tower sits on top of this, so unfortunately I wish we had the other part so you guys can show you, but the cam tower sits here. That's where the cams are, whatnot. Spark plugs are here. Now, like I told you, these are being cut Unknown why they've been cut, but they've been cut. We're just glad to have it. Check it out. Let's look at the deck here. If I am not mistaken, and I can double check, these do have one of those water baffles that sit here. It's very familiar design. I still love to do these. Actually, I was curious to see it on the cylinder head. Look at this. Hello. So the 2GR had almost like jets here that spray water, spray coolant. This is like rounded. I like that. Actually, I take that back. Take that back. Here they are. This is what I mean. Like they have a hole and coolant comes out of here. And here's what I'm noticing. We have a head gasket. Not sure if it's this side or the other side, but yeah, I think that's the other side. Is it? Are you the other side? Yeah, it is the other side. But I'm noticing, like, between this and the edge, I see the imprint of the gasket. And that's a pretty decent surface, because this is what used to happen to the 2GR. This will be a little bit closer to the edge. You don't have any gasket material here. If any kind of corrosion or salt gets on the outside, it starts slowly eating through the gasket, and then this just opens a port, and so you start having an external head gasket leak. So we're hoping that is not the case, because that's a pretty big area compared to the 2GR. So that's good. And by the way, this is where your direct injectors, this is where they actually come out. You notice that that's inside the combustion chamber. And that's where they go in right here. And so these are cool. I think let's pull the second cylinder head out. I don't think there's much to see. It's pretty much the same thing. Now you can see this cavity pretty clearly. That's not a valley plate, folks. Just making sure for the folks out there that are concerned, that is not a valley plate. Before we move further, I want to show you something else. Talked about the chain being kind of not giving me 2GR vibes. Let's talk about the guides. Recently we did a video on was it a 2GR FTS, the 17 Highlander. Talked about the guide that was worn. And here's the interesting part. So this style guide, see if it's steel backing, black plastic. This is the iconic kind of, they put it in the engine in the factory and forget about it style that the Toyota have used in the 2GR FE. And we never had guide problems. But then we have these yellow ones. Now, at least this one, unlike the 2GR FTS, this is actually aluminum backing, not all plastic like the 2GR FTS. So this is the similar guide to the 2GR FTS, the top, but not the bottom. But I don't see anything on it. I mean, this was an in-service engine that had an event. Same thing with this one. This one has a little bit, but nothing over the top. I like that this engine may be guide problem free, because I like these guides. See this one? No, it's fine. That's just like a color difference. The block. This is where we got big problems. Not really. I mean, they recalled them, and I hope they figured out what the heck happened. They said it is machining debris. Of course, they're the manufacturer. They know what's going on. They're not going to go out and lie to the world, I hope. Here's what we have here. This is a spiny or spinny block. This is how they do the cylinder walls. I want to turn this engine. I hope it turns. We actually haven't turned it. But you notice one piston is missing. So that is the piston that had an event. This piston made noise. This engine was not part of the recall, not a dealership. It has nothing to do actually with any of this stuff. It had an event that caused it to do that. It was replaced outside. But here's the interesting part, which is just shocking to me. Look at the cylinder walls. Look at the amount of wear on the cylinder wall. Right there. Even Jose was surprised by how that looks. That's not good. Same thing here. This one, the one that had the event, it actually has, it has quite a bit of wear. This one as well. we'll see what we see, folks. But this engine basically has nothing to do with the recall or anything. Ran out of oil because of a mistake. So here we are. Started knocking and whatnot. So unfortunately, we don't have the rod bearings, but we do have the piston out. And I want to look at one thing. Why do we have this wear? Was it simply because it ran dry? Or what's going on? We'll tear the short block down because I'm already not seeing something. I'm seeing something I don't like. So this is a compression ring. Just take it out, check it out. These are low tension rings. Just pull them with your hand. This one, of course, is not cooperating. This is not how you do this, in case you're watching and learning from this. Not how you pull a ring. But the compression ring, top compression ring, does it have any markings? Yes, it does. Is it tapered? Doesn't look tapered. It's kind of full of gunk. My eyes are not working anymore. Let's pull the second one. Again, this is not how you pull a ring. We're just trying to get this through. This one is tapered for sure. Kind of similar style, actually. I mean, that's how every Toyota engine has been. Top ring has no groove, at least modern ones. Second one has a groove, or tapered. But here's my concern with this. You see this oil ring? I mean, that's yeah, it does move, but it doesn't really turn very easily. And that's the problem. That's a lot of gunk on this guy. Right, again, it's not a measure, but kind of an odd shaped piston, I gotta say. Look at the edge here. It has this, almost like I want to put it on my table. It's a nice design, but interesting. That's kind of strange, this area. I don't like the finish on it too. Kind of rough a little bit. Very interesting shape though. Oh, is this an A? No, it's an N. It's just my eyes not working. I wonder if they still have, so here's the thing with Toyota engines. They'll have, at least in the past, they'll have 3-style pistons. The piston is the same. It's the thickness of the pin is different. They have ABC pistons. These don't, yeah, they do have a B. Potentially that is the case. So we'll take some of the other ones out. But usually what they'll do is they'll put the number that is on the rod bearing here, and then they'll stamp the piston. But here I see 2GBZ. I don't know what the Z is. Don't know what the G is. 2 maybe the rod bearing. B maybe the piston type. That's how they've always done it. Let's take a look at this cap. This is no fancy cracked cap or anything. They do have these guide pins, so you know the direction. Just go in here. That's how this goes. This one I don't think is gonna go, because this is the piston that had issues. Been thrown around and whatnot. Oh, actually, I think this cap has been elongated because it's been beaten by so it doesn't want to sit. We'll check some of the other ones, but they don't have cracked caps on these, of course. It's not a high-performance engine, but they have the similar design to other Toyota engines. Nothing really strange here. Now we get to the most important part, the short block. This is where they have issues. This is, I guess, the recall stuff. We're not looking into that. I just want to kind of explore the engine, but let's turn this around to the bottom. This is what I've been wanting to look at. So, here's the thing with this engine. This is something that they're starting to do with some of their newer engines. So, the crank, this is a crankshaft right here with this is very worn down. Talk about it in a bit. So, the crank is bolted to the block, and then the rods are bolted to the crank. That's how engines work. In this particular engine, we don't have individual caps. We have kind of a cradle that sits and contains all the caps. Now, from an engineering standpoint, this should be stronger than individual caps, because now you have one complete assembly that is housing everything, and it's bolted down, and they're all kind of sharing the force that is pulling on them. But some engine builders and engineers and whatnot have said that this design is not as strong as a 6 main bolt, because this technically is a 4 main bolt. Again, time will tell. However, this engine, they did have a recall. It's machining debris, affecting, usually, at least from what I can see, always the first main cap, sometimes some rod caps, but mainly this main cap. The bearing gets wiped out and everything goes downhill from there. Here's what we're gonna do. Let's tear this engine completely down. Let's pull the rods out. We'll look at the rest of the rod bearings, because this engine did have an event where it ran low on oil. We'll see if I'm not really sure if this falls into the VIN number of the recall or not, because this is not why this engine went down, but I want to see how this main bearing did with such an event like this. Let's take out one rod bearing. Very curious to see it. Okay, that's interesting. So these rod bearings have a coating on them. This is something we haven't seen before with Toyota bearings. You see that coating? See how it's slightly worn off here? Huh. This rod bearing, I mean, other than measuring oil clearance, looks decent. But I do notice one thing. This is a pretty strange thing. It does not have a lock groove. Most bearings, they have a lock ring where it's a little groove that goes into the cap and into the rod on the other side, where the bearing kind of gets located in. This one doesn't have any. Huh, it's kind of interesting. It's not bad. I'm not going to measure oil clearance on this, although it's kind of not fair for this engine, but I'm just kind of curious on the main, especially the first one. Let's pull this piston out, and we'll see. Is this going to come right out, or is it going to fight us? It's going to fight us, I feel it. I don't even know if this engine turns. Do you turn, buddy? Let me grab something to turn it. Don't do this to an in-service engine, because you're not supposed to grab it like this and turn it. Oh, this one turns. Cool. Because this scratches it. Okay. Interesting. I'm just curious. I actually forgot to turn this engine, see if it turns. It turns. There goes the bearing. Same thing on this bearing. Let's take a look at it. What's that coating? Does not have the locators. Huh, that's actually pretty interesting. I mean, it's gonna be enclosed in this space, but isn't that bearing going to have a tendency of wanting to ride on the edges? Or put a load on the edge because nothing locates it here? Huh, it's kind of interesting. Same thing, it has some kind of coating. It's interesting. Because usually you just don't have anything. At least on the 2GR ones. Here, on this one, see the same thing. Oh my God. Again, this is not a good measure, but this oil ring is just not going anywhere. And if that gets seized like this, that's not good. I mean, we have wear here. Well, again, this engine did have a catastrophic event. Here's what I'm going to do. Take all the all the rods out, all the pistons out. Then we'll focus on this main bearing, because that's really what I'm curious about. Okay, we gotta this was not a, yeah, so this is how this should look like, and that is a blued rod bearing. Not good at all. Let's tear it down and see the rest. Okay, that's 6. Just from working on engines for a very long time, yeah, these bearings will be completely done, because this crank is not turning smoothly. And if I'm building an engine, this is how my crank is. So I think we're gonna find some other damages here. Let's pull this cradle out. Wow, this is either very high torque or the event had something to do with this. I'm not going in order, folks, because this engine, of course, is done. We're just learning about this engine, fortunately, from one that is not in service anymore. Ow, these main caps are not going. Let's try it again. Wow, this is me. Wow, this is very interesting. It's starting to slip. You know what? There we go. Well, maybe we need to increase the heat. Now this is what I'm talking about. We're gonna do this. Yeah, that worked. Wow. I don't think that's normal. I think the event that this engine had something to do with these being like that. We had to cut because this thing kept turning and turning. Jose had to hold it. We got it. The same length bolt. They have like a step to them. They are actually different bolts. This one is thicker and has more thread. This one is skinnier here, has less thread. Actually, it might be a different size. Yeah, it is a different size. Interesting. I mean, they are like that. Well, now we pull the cradle. I already forgot a bolt here. Okay, now let's pull it out and see what we see. Of course, they do not leave you. Oh, here we go. I was looking for this. They usually do give you a prize spot. See, that's what I don't like. This is something a lot of this kind of technician community has been talking about. You see how this bearing just came right out? That's kind of a problem. Okay, now we should be able to pull it. Let's see how things look here. Okay, that's pretty interesting. So these bearings, of course, have wear on them. And this one actually got stuck here. Yeah, here we go. That's the problem. Do you see a problem? We're not going to be able to measure oil clearance. This one has a lot more wear than the other ones. That's very interesting. I wish we knew more data on this engine just to understand. But the same thing. Its main bearings do not have a locator. They do not. And same thing, they have this coating. I haven't seen this coating from any other Toyota engine. Interesting. But this first bearing, I mean, look at this. I want you to see this. This one kind of sits here. You have to push it to sit it in. This one, it's pretty interesting. I want to see the other side because we definitely have bluing here. See this bluing? Obviously, this engine run low on oil, so it's not. But why does this one take more than the rest? I would think the last one would be the one to take the most. Unless oil flows this way into this crank, then that would make sense. Because the rod bearing that went was this one. Unless the flow is backwards, and these are actually the last two, then it would make sense. But then this would have a little bit more wear, and then as we get closer with lower engine oil pressure, this is going to happen. Let's see, this is spinning already. There goes the bearing. There's the crank. Interesting crank. We'll look at this in a second. I'm just curious about that other bearing. Okay, also has more wear than the rest. See this one. Look at this one. This one took the brunt of it. This one is still sitting in its place. It does have wear on it. It does have discoloration. But not like this one. And that's where, like, all the ones that reportedly failed, it's always this bearing. You'll see it like sticking out like this. This one, I mean, it's on its way out. See that? I mean, I'm just curious. Okay, let's say this bearing is shot. Assuming these bearings are the same. See, this one is the same. Yeah, it's just the bearing went down. So I was thinking, what if this was open? Yeah, it's just the bearing. Do see wear on all of them though. But interesting that this one would take the brunt of it. When this fell out, I didn't see which direction it was. But did it walk out and do this? That's the interesting part. I wish these had a lock tab. They don't. Interesting. Well, I guess they don't. Let's continue our tour of this engine. They got a recall on this. They figured it out. Really, they fixed it for everybody, and we don't hear about it again. Here's another interesting thing. This engine has 2 jets per cylinder. This is to cool down the piston at the bottom. I like this. They've always used this style. They have 2 of them per. Interesting. It's kind of a... I do like the old ones that had the 6-bolt mains, but this is what they did here. But here's the interesting part. I actually want to look at this. So we have 2 bolts. Where are my bolts? Put them somewhere here. Here we go. We have 2 bolts. They're actually smaller thread. This is definitely smaller than this one. Wondering where they go. Big one goes here. Small one goes here. Yes. And, maybe my eyes are deceiving me after all. No, see, it's not the same. That's what I figured. So just looking at it, they're not the same thread. Yeah, if you look at it close, this one is coarse thread. This one is fine thread. And I'm wondering, I actually want to measure it. I want to say this is a 150. This one is 175. Let me grab my measure and we'll check it. This big one is a 1.5 thread pitch. And this small one is a 1.25 thread pitch. It's pretty interesting. And I think the reason for that, I've been looking at this off camera a little bit, because they have this guide here for the caps to locate. And if you put a bigger one, this area right here between where the guide ends and the edge will be smaller. I'm assuming that's why they did it this way, that this bolt is bigger than that one. Very interesting. But I still, I took a small break from filming. I was looking at this. This is the thrust bearing of this engine. There's definite side load on this. And this also looks like it has some kind of coating. Interesting. This one has even more. I went to, because some folks have talked about, and I'm also curious about it, is this bearing walking in the ones that were affected by the recall, whatnot? Hard to tell. Toyota knows, that's their business, but here's just what I'm looking at. Now, this engine, not a good example of this, but this bearing walking out, if it walked out, on this journal of the crank, right here, would just hit the inside. On this journal, it would hit the inside. Same thing on this journal. It could walk out that way, but on this journal, it has an open passage to come out. So I wonder, in the updated engine that has no debris that caused this event to start, where the bearing becomes, of course, when the bearing is this loose in this opening, I mean, look at this gap. When the bearing is this loose in this opening, of course it's going to walk. But I wonder if the updated engine that doesn't have debris and everything is good, did they do something here? That would be very interesting to find, because I'm just fascinated that this bearing does not have a locator pin. Now here's another thing about this. That locator pin is not a giant bolt like this. Of course, if there's any kind of side force, it will rip that little guide and it'll bring it out. Just like this bearing, worn down, became smaller. This guide is the same material. It'll just rip right out when there's something abnormal pushing it. But under normal operating circumstances, that is not the case. So here's what I want to do. I want to get my thrust bearing back. It's the first thing. I'm going to put the worn down bearing here just to see. So we were looking at the other side bearings, but it should be the same story. Here's that one. Thick one goes in the back. So here's what I want to do. I just want to experiment a little bit. So learning as we go. This one that is very, very loose in here, and it just doesn't even sit. I'm going to swap it with the back ones, because these two back ones, the first one and the last one, they're the same. So I'm just going to put this one here. We're going to set the crank down. I want to see what kind of side-to-side movements we have. What does it do to that front bearing? down, probably because of this bearing. Ah, that's why. There goes that. He's not cooperating. Thank you so much, Jose. Thank you. I notice this red paint, tip of this red paint. I wonder what they're referring to there. You know what? This is what's gonna lock up this. So let me just take it out for a second. Let's just for experimenting sake. Here we go. That bearing was not letting us sit. So, is it possible that from the normal operation of this engine, this bearing would walk out? Right now we don't have any force on it. I just don't like that these don't have any locating tabs, honestly. There must be a reason they're not going to design an engine and not forget something as simple as that. It's just strange. That's the only strange things about this engine that I see. See now, not super smooth, but it's better. Because of this last bearing, well, this was actually the first bearing. Very strange wear pattern on this bearing, and that's what I don't understand. I mean, yes, this engine ran low on oil, that's fine. But why is only one side severely worn down? One side is worn down, but the normal wear. Same thing with the other half. See that? Like it's worn down on, I'm sorry, it's like that. Worn down on the edge. Almost like this was riding on the edge. Although this engine, this part of the engine has never been torn apart. It just was replaced as is. But I didn't see it sticking out. It was more here. And I'm noticing another thing. Grab the other cap. See this bearing? Sits in perfectly. This one is like deformed. It doesn't want to sit. It's almost like it's curled in. Maybe we can see it. Might be something minute. Yeah, you can kind of see it. Like if I put these bearings maybe against flat surface, yeah, you could definitely see it here. Put them right by side. You can see that this one is curled in. You see the edge? That's very interesting that it curls in. I mean, if you have wear, this bearing will be loose, but why is it tight? It's pretty interesting. Look how tight this is. That's pretty tight. Interesting. Same thing. Interesting. This is just fascinating to me. It might be boring or nerdy to you, but it is fascinating to me that how this wear pattern is strange on this bearing. But that's what happens to engines sometimes, unfortunately. Now let's talk about kind of the recall, debris and whatnot, because we talked about it in the video. Let's kind of follow up on that. So looking at this engine torn apart right now and how the wear pattern, and the wear is more this way than it is this way, I wonder one thing. Where is the engine oil flow through the crank? Is it this way going that way, or this way going that way? Because right now what I'm seeing here, from how this engine ran low on oil and how this happened, it tells me the oil flows this way, not this way. Because this took the brunt of the impact. This one also took the brunt of the impact. But if you really look at the crank, now this is not, gotta measure and whatnot, but I see wear down here. I see wear down here. But the rest of the journals, not really. Just visually looking at them. I see a little bit of bluing here, but this bearing was not completely torn down. Like, well, I don't have this one, but this one was completely torn down. Same thing here, same thing here. Same thing here, same thing here. So I wonder if this oil flows from the back to the front. Doesn't look like it in the diagrams, but it's very possible. Very interesting. So we can analyze the passages, but I mean, it doesn't make sense because the oil pump is in the front. So oil will flow this way into the first, into the second, into the... This is very strange. Because if you look down here, yeah, it definitely flows from the front. This doesn't even make sense. So there is a galley right here, and this is where the oil is going to all of these. If I put my light here, you can actually see my light right through this opening. See my light? If I send it more in, you see light, see a little bit of light here, and a little bit here. So oil is definitely flowing this way. So it's flowing here, going to this, going to the next one, going to the next one, going to the next one. So this is definitely the last one. Because this galley ends up, there's a bolt hole here. No, this galley is closed at the end. So the oil definitely flows this way. But there's another oil galley somewhere in this vicinity. I wonder if it's fed through, because for the jets. So now it flows this way. That's where the oil flow goes. I mean, everybody is very curious about the machining debris and whatnot. I'm not really sure what the date of this engine. I mean, this engine might have not had debris to begin with. We don't know that, but just trying to understand how could the debris affect, seems like always the front, never the back bearings, at least from what everybody have shared, technicians and whatnot. But the only theory here is, okay, we have oil going this way into this galley to feed everything. If this galley had a lot of debris where it's completely clogged, but I mean, I don't see how that would be the case. I don't think it's possible, unless, you know, I'm seeing something here, like, no, it's in the casting. Thought it was like debris that comes off, but that's the one thing that is interesting. If this galley right here, like the first port, was clogged, this could be the case. But then this debris would have been sitting, because this is, the engine right now is upside down. If this debris was in this one port, then the debris would be sitting right on top of the bearing, which is, I just threw the bearings around. Maybe it should be more organized. This would be the bottom bearing. See, this is the part where the bottom bearing has a opening, so the oil will flow here as well and then goes around. So this doesn't support that theory that it's just the debris is just sitting here. If there was debris in this galley, it would immediately make its way through here into here, unless it's like we're talking about, oh, I don't know, a giant chunk, like you left that little bolt here, and then it'll clog this and it'll starve this bearing. Otherwise, you'll see it. Unknown. That's very interesting, but they figured it out. I mean, if they're not going to issue a recall, just put the same thing back and hope for the best, costing them a small fortune. But very interesting journey with this. I was very looking forward to tear this down and kind of check it out and see what's what. But the last thing we want to look at is the oil pump. Let me move some of this stuff around. So here's what I'm seeing here that is pretty interesting. So the oil pump sits here, but then when I look in the back, there's this entire contraption here. I see the vanes of the pump here. Here's how the oil flow is going to go, and just going to make sure that we get this right, because the oil filter is here. So I'm assuming pickup into the pump. I want to see where this part sits. This part, let me flip this engine around. Let's see. So if we get this, this is gonna go around here. Okay, so that part is on the cradle itself. Let's take a look. Which, by the way, on the cradle, I forgot to tell you this part. The caps are actually steel. So do you see how they're like almost, the cast was around it? Because this is aluminum as a magnet. So the caps are steel. They're not aluminum. There's no such thing. Aha, there it is. This one is the oil pickup, yes. So the oil pickup goes right here, goes through this big passage, and then goes here, and then will follow the flow of oil, which I think goes here, which is the oil filter, and then it returns. What is the first thing it feeds? This one is gonna be this one, which is, where do you go, my friend? I think this is just a pass over to here. I see actually two passages. There's one. Definitely see a side passage. Maybe it's just my eyes deceiving me. No, my eyes are deceiving me. So oil comes in from the oil pan, goes here, goes to the filter, comes back, goes into this passage, into the block. Where is this area in the block? I'm gonna turn the block. Oh, okay. Somebody's happy. And is this here? Let me just see real quick. This is the front, this is the back. It's actually this one. So it goes right here. Oh, what are you, my friend? Oh, that's a galley that goes, I think this is the galley that feeds these, the jets. And yeah, that's what feeds the jets. But I wonder, how do the other jets get oil? Maybe through here? No, that was the main one, right? Yeah, that's definitely the main one. No, that is not. Maybe it gets it from here. Yeah, that is it. It's connected right here. So if you see it, it's connected right here to the passage of the oil for these jets. So there's that. And this passage at the end, if you look here at the back, they actually put what looks like a freeze plug, but it's just a plug for that galley. Another one here. They have two plugs for these. And I don't know why they have a plug, probably for casting. But, so we figured that part out. We have, I'm assuming that's the one that sends oil to the other side. So this one for the jets, this one for the jets, then oil kind of comes up. I saw some debris here. Oh, it's interesting. Then this one, that very top one, actually feeds here, which is the crank galley, the main galley that feeds all the, so no. And so our theory of oil flowing from the back to the front is not the case. It flows right here. And then from here, I'm seeing another, something here. This is actually the idler that gets oil here. But how does it flow to the cylinder head? That's what I'm curious about. Guess. Yeah, it's probably shared with the block and then it goes up. I just want to see it. Because these are head bolts. These are oil returns. This is coolant. And this is coolant. How do you feed their cylinder head there? And there's something feeding this one. Let's look at the cylinder head then. It's got oil got to come up here somehow. Here's the main oil galley. Is this it? Yeah, this is it. So, I'm wondering, what have we here? This is, I think, what feeds it. These are two. So do you see this main passage here? This is what's going to feed your cylinder head. Your lifters, and then it goes up into the upper part, which is the cam tower for the cams. But where does it get an oil from is what I'm curious about. I see this opening. This is in the back. That's pretty interesting that it's in the back. I wonder, we have something here that feeds it. I guess that's the mystery. We'll leave for another. Obviously, the cylinder head gets oil somehow. But we don't have issues with the cylinder head. It's the main bearing. So it's still a big mystery, honestly. Toyota knows what it is. They issued a recall. I hope they fixed it. There's folks are really upset about it. I get it. We paid a small fortune for this truck. I did the same. I'm in your boat. Love the engine. I really like this engine. We'll use this as kind of an update for this truck. I just gotta say, and folks are very upset about this, and I get it. I understand. But one of my favorite things about this whole truck is the engine, and the second, tied up with it, I wanted to say the second thing, is the ride quality. I understand leaf springs are, heavy duty and you don't have issues, but the coil spring really makes for a nice ride. I mean, most of us, I drive this truck. Yeah, we use it for the shop here and there to get stuff, but you also got to take your family in it. And if it's just bouncy and really uncomfortable, that kind of takes from it, where now you're stuck dealing with the ride. That's one of the things I love about this truck. Really don't like the paint, the looks. It's a car that blends in the background, but Love the engine. It really has good, decent power. But surprisingly, it's getting better gas mileage than the GX that we have. I own the 23 GX, if you're not familiar. Obviously, it's not a sports car, but I do like how it handles. You know, you drive on the highway. It's a big behemoth truck. Drives pretty good. I like it. That's why I wish from Toyota a few things with this. I mean, we're gonna kind of change the subject. The main thing was checking out the engine and seeing what's inside, but I wish of Toyota a few things with this truck. And same thing with the Sequoia, same thing with, I guess the LX also has the same issues with the engine, and folks are complaining about them. First, right now the recall is only on non-hybrids. I get it, recalls are expensive, whatnot, but the hybrid community, I'm one of them. Although I hope mine doesn't have any issues and we don't extend things and whatnot, but hybrid community, gotta get them covered too, because there's a problem with the engine, there's a problem with the engine. Just do the Toyota way, the right way. Take care of folks, move on with life, and get it fixed, get it taken care of. We're good. That's the first thing. Second thing is, I gotta say there's a lot of little annoyances with this truck. Starting with the paint. Paint is not the Toyota standard. Little stuff, not the main paint, but like panels, sub panels and whatnot. And then the interior. So we were just coming out of winter here filming this video. I finally can drive this truck and not have the entire headliner rattle. Now, can I fix it? Yes. I just don't have the time to be working on my own car. That's why I bought a new one. Now I have to possibly pull the headliner down to figure out a rattle. Now, do I have a warranty? Yes. I am the warranty for my cars. I just don't feel comfortable taking it to a random dealership and have a random disgruntled mechanic that is underpaid for jobs like this. And I get it. That's the problem. So that's the problem. To me, honestly, the engine problem, as severe as it sounds, if they know of a problem, they recalled it, fix it, we're done. That's it. But the other stuff is, you're paying a lot of money for these trucks. I mean, cars have gotten very expensive. Interior is nice. I like the interior, but the quality could be better. That's truth have to be said. Quality could be better. It's not just the engine, and the rest of the truck also have issues. That's little stuff, but it adds up to a lot when you're paying this much for these trucks. That's my honest opinion, because I love this truck. Mrs. Carcano said, we will never sell this truck because we really like it, like everything about it. And I do, but I just wish the little stuff could have been better. That's the main thing. Folks, this is the V35A. Took a look at it. I hope you learned something new about it. Now, the very important question that folks ask me all the time, are they cheaping out on things? Is this engine kind of a fragile, horrible engine? Some things, yes, like the chain, it was kind of a surprise. The coating on the bearing is a mystery to me. The lack of a locator tab is interesting. Pretty sure Toyota engineers, they are engineers. I am not an engineer. But it's just strange that I haven't seen engines like that, at least in Toyota land. But there's also good things, like the front timing cover that doesn't have a passage. Another thing that I was kind of surprised by, that they decided to do this, and it's not good. The location of the PCV valve, not good. All the way in the back. And then we have this thing. There is no heavy oil here. So this is not like an oil container or an oil cooler or whatnot. But still, this is going to tend to have all kinds of seepages around it. It's kind of a job to get to it. I wish they would have learned from the V8 not to put stuff in the middle of the V. That would have been nice. I mean, we still got some space here to put stuff on the side. And the other thing is the vacuum pump all the way in the back. Hope we don't have issues with them, but that's kind of a bad spot. But these are my observations. I mean, I really hope they figured out what happened with the machining debris, fixed that, moved on. Folks seem to be happier that they're getting new engines and things are good. They can take their long trips comfortably knowing the engine's not going to just strand them and whatnot. But interesting updates. I mean, this engine, I was from day one. If you remember the first video I did on the Tundra when it came out, I was fascinated by it because, folks, on an engineering level, there's a lot of things that are very interesting with this engine. We didn't even get close to covering any of them here, but I just wanted to see the nuts and bolts of this engine. And I hope you enjoyed the journey with me and you learned something new. And until the next video, folks, may the Lord bless you and keep you, and you have yourself a wonderful day.